Well, good morning, good afternoon, good evening, wherever you are in the world. I'm hoping you are able to join us comfortably at this webinar. Today is a special launch event for our latest State of the World report, which looks at the evolving global energy landscape and examine what the sustainable energy system of the future will look like and how they will operate. As we look ahead to a net zero and zero carbon future, the issue raised and discussed in this report are important one for our industry, and I'm pleased that we are discussing them today. Today's webinar is entitled Developing Tomorrow's Sustainable Energy System and Building a World that is Best of Great in Generation and Complex of Energy. We are grateful for the support of our webinar sponsor, Schneider Electric, and you'll be hearing from them and representative in the near future. Moving on in terms of the agenda for today, we have a very interesting report, which, from my understanding, this State of the World report form an important part of our FIDIC policy work stream, exploring important issues that FIDIC consider are very important in terms of our regions, country, local, and community. Now, I'm just going to pause for a minute here and just a few words just to set this scene. The Sustainable Development Goal as set up, actually have 2,257 days away. If we take out weekend, we basically have approximately 1,600 days to deliver this wide-ranging set of goals to improve global sustainability. Beyond the SDG, we also have the challenge of meeting the net zero emission by 2050. I'm told we got 9,561 days to go. It's challenging, and all countries are coming together trying to get a grip with the challenge. Are we going to achieve it? The Future Leader Leadership Forum recently produced a recent report in collaboration with EY, and it estimated that we need 75 trillion of investment. And this is really purely just trying to catch up. And if we are to meet the net zero, this need to double to 139 trillion. And the global countries are looking to ways to reduce reliance on fossil fuel-based heating, a move to electric vehicle, encouraging renewables, and much more that needs to be done. The time, for us is now. We need to act. This form sort of a report that we produced go through back, over the last 10 years. But in the last 2 years, we've improved that report, and we now produce that report on a regular basis. So I'm really pleased today that we are actually launching this, and I hope that as we launch the paper, it will be an opportunity for people to engage and to engage in the discussion. So I'm going to move on to the next item on the agenda. Looking through, we have a fantastic, lineup of speakers, which I think is quite interesting. And my speakers, are lined up from different parts of the world. I hope we got all of them. And if we haven't got them all, but at least I'll go through the list. And those who are not with us will join us to move forward. So we have Harry Stockman, DC expert with DC System from Netherlands. Thank you for being with us. Ahmad Makkieh, DC Business Development Leader at Schneider Electric from the UK. I believe you are in Scotland, and Scotland is still part of UK. You got Luigi, who's from Milan, Pellegrino, BESS Power Device Manager at Hitachi in Italy. Welcome on board. We got Mauro Monge, Global HVDC Product Manager at Hitachi Energy in Sweden. And I do believe that Theodore Paradise will probably join us later if he's not here. So with that in mind, it is my pleasure to introduce our Basma Eissa, policy analyst, to give us a very quick intro into the findings of the report. And thereafter, we'll have a Q&A session, which I will start off with the panelists. And then we go to the floor and we pick up questions from the floor and we try and wrap up on that. So I'm looking forward to an exciting time. And I'm going to hand over now to Basma to take the floor. Basma, it's your floor. Thank you very much.
Thank you, Nelson. I would like to start off by presenting the findings from our State of the World report about the development of future energy systems, which delves into the fundamental question of whether historical decisions such as alternating current versus direct current, centralized generation, and long-distance transmission still serve us well in our journey towards a greener, sustainable, and community-based energy model. In a nutshell, the answer is a firm no. As you will discover through this report, there are numerous compelling reasons why a more diverse set of energy systems can not only offer enhanced efficiency, sustainability benefits, and resilience, but in some cases can even emerge as the preferred solution for new energy networks. As engineers and industry leaders, our primary task is to navigate the intricate path towards achieving crucial targets like the Sustainable Development Goals and reaching net zero emissions. This path demands a delicate balance between various technical and societal requirements. It drives us to respond to the multifaceted challenges detailed in this report, emphasizing innovation, policy development, sustainability, and community involvement as the driving forces for progress. Our first key finding from the report is that clients should procure solutions with specific links to the Sustainable Development Goals outlined. The Sustainable Development Goals play a vital role in the development of economies and society. These goals are by no means simple to achieve, and if solutions are to be procured to create the best outcomes to align to these goals, all projects should have a clear statement of intent as to the aims they are trying to achieve under the Sustainable Development Goals. Our second finding is that modern power systems involve a complex delivery of multiple types of projects. In the context of modern energy systems, engineers are confronted with multiple challenges on various fronts. Central to this complexity is the need to address the Sustainable Development Goals and achieve net zero emissions. The report highlights how, in this context, the engineers are confronted with the challenges and how the necessity for engineers to be involved in the very early project conception and feasibility is very important, as our findings reveal that by engaging engineers in these preliminary stages, the intricate aspects of assessment can be comprehensively explored, as engineers with their expertise can identify potential challenges and risks that might otherwise be overlooked. Our third finding is the significance of societal and community focus. As we progress towards realizing the Sustainable Development Goals, the infrastructure sector must evolve into a more community-oriented and customer-centric entity. The report underscores the paradigm shift from merely serving the interests of public or private sector clients to becoming more closely attuned to society and its needs. Our report demonstrates that community engagement and addressing societal concerns has become paramount. It is not just about delivering infrastructure. It is about doing it in a manner that benefits communities, engenders trust, and supports broader societal goals. And in that sense, inclusivity is key, and community well-being is an integral part of our mission. And our fourth and final finding in the report is that the significance of the role and of policy frameworks and its importance. Policy frameworks play a pivotal role in shaping the success of infrastructure development. Whether it is the revitalization of existing infrastructure or the promotion of new infrastructure in developing nations, the report underscores the importance of flexible and tailored policy frameworks. These frameworks must be aligned with the unique goals and aspirations of each country. A one-size-fits-all approach is no longer tenable. Instead, the report advocates for frameworks that are adapted to the specific needs and objectives of each nation. This is crucial for promoting sustainable development, addressing local challenges, and fostering progress. In conclusion, FIDIC's State of the World report acts as a compass on this transformative journey towards a more sustainable, resilient, and community-centric energy future. It does not only challenge the conventional norms, but it also provides concrete recommendations for change. The report is a call to action and a blueprint for reimagining our approach to energy systems, presenting a roadmap of collaboration in our shared quest for a greener and more sustainable tomorrow. And therefore, I would encourage everyone to download the report, and I'm positive that you will discover valuable insights to apply within your respective sectors. Thank you. Back to you, Nelson.
Thank you very much, Basma. You know, a call to action. I think that was the word you said, call to action. And it is available now to be downloaded if you really wish to. I'm not really going to tap into the talent and pool of knowledge that we have within our panelists. I'm starting off with Harry Stockman, and you may wish to do a very quick introduction of who you are. What I'm looking for, Harry, is just your initial reaction. You've had opportunity to see the report, and after your introduction, just give 2 or 3 minutes perspective on the subject, and then we go to the next candidate. So, Harry, the floor is yours.
No, okay. And I'm Harry Stockman. I'm a whole workable life. I was a DC entrepreneur, and since 2020 taken by Schneider, so part of the big happy green family. And incredibly happy that Schneider makes this progress on the life work what we started to make DC technical possible. And I was driving this in the past, and now I'm driving it in standardization and in everywhere I can to make DC successful. So that is and for some feedback about the report. Yes, I'm incredibly happy with the report because it contains a lot of DC, and it shows that technical solutions are needed in our existing infrastructure system. So this is for me very, very clear, and I'm happy that the report put that clearly out.
Thank you very much, Harry, for that quick introduction there. Ahmad, I'm Makkieh from Schneider Electric. Do you want to do a quick introduction, yes, and also your initial take on the report?
Yeah, thank you, Nelson. Thank you. Good afternoon, good morning, everyone. My name is Ahmad Makkieh. I'm a DC business development leader at Schneider Electric.
And you said to me you are in Scotland, which I still think is part of United Kingdom. Is that correct?
It is still.
For now.
So yeah, so it is like a bit always like this kind of discussion about Scotland and England, but yeah, we're still in the United Kingdom. So I really also thank you, FIDIC, for the opportunity to join to be part of this webinar, and I'm really genuinely looking forward to engaging with the forward-thinking individual here in the panel and the audience, and discuss the significance of this report on shaping the future sustainable energy system, and of course to share Schneider Electric insight on the topic of the DC system. So today, just I thought to also give 1 minute or 2 minutes about the report in general, as I share some industry point of view. So we are not just talking about energy. We are diving deep into a world of innovation and cutting edge technology. And imagine a future where we don't just use energy, but we use it wisely, sustainably, and responsibly. So it is not about just a kilowatt or circuit or a grid or what's happened today or tomorrow. Our big picture, as Basma and Nelson mentioned, to reshape how we think about energy, and to do it in line with the big goals like sustainable development goals, and meet the objective of achieving a net zero emission globally. So from my message, let's dream big and make it happen.
Thank you very much, Ahmad. Dream big and make it happen. And it's not just about talking about numbers, but actually doing it. That is a very good intro. Thank you very much. Luigi, you are from Milan.
Yeah.
And I think
hello, everyone.
Can you do a quick introduction of yourself and give me your very quick view of what you think of the report so far? Luigi.
Okay, thank you. So my name is Luigi Pellegrino. I'm an electrical engineer. I always will be worked in the battery energy storage system field, and currently I'm in Hitachi Energy as a power devices engineering manager. Yeah, what I can say is, first of all, thank you for the invitation to this panel. And yeah, I think that this report will describe the power system of the future in some way. So there are a lot of topics, important topics that we have to face and to tackle. And yeah, in my opinion, I provide also my personal point of view, of course, concerning the battery energy storage system, but I see a lot of topic that we should touch in the next years.
So thank you very much, Luigi. So what I hear for you is not just about, big picture, but is a power system that's really looking to the future. So I'm going to bring on that, is it Mauro, please. Mauro,
Yes.
from Global Product Manager from Hitachi, from Sweden, please. The floor
Yes,
is
thank you, and good morning, good afternoon, and good evening, everyone. Yes, my name is Mauro Monge, located in Sweden. I'm Global Product Manager for HVDC system. So, as some other colleagues, I'm really close to the DC. I've not been working always with DC. Actually, I've been in the industry since 2006. At that time, was mainly with power electronics, so like STATCOMs and other solutions. I would say what I really like of the report, first of all, is the timing, because I think we are really in a phase right now where the energy system globally is under something that we could almost define like a revolution if we look at the speed and the amplitude of the changes that are happening. So we are more or less trying to do what we have done in 150 years before, but probably in some few less than 10 years. So how to, let's say, from one side we have challenges, but we have also a lot of opportunities, which are technology, new way of doing things. So the question is, how can we employ these technologies at scale and with speed? So to spread both, let's say, the possibility, but then also to highlight some of the challenges that sometimes are not only technological challenges, is really framework kind of challenges. This hopefully will help the whole industry to move in the right direction, but especially faster. So happy to be here. Thanks for the opportunity.
Thank you very much, Mario. I think the comment you made, there's quite a time. You said timing is good, challenges and opportunities. And I'm really pleased that we got Theodore Arnold, who's joined us from United States. It must be good morning to you, Theodore. And I hope, which part of United States are you from? Yeah.
Nelson, I'm on the East Coast of the United States. I'm joining you from Massachusetts this morning.
Excellent.
Good morning to you all.
Excellent. Well, good morning. I'm glad you're able to join us. That, where you are is one of our past president home. So I'll need to have a chat with you about that. But it's good to have you on board. Would you be kind enough just to introduce yourself and tell me in your 2-3 minutes, what's your take on the report?
Sure. Thanks, Nelson. By way of quick introduction, I'm a partner, I'm a lawyer in the global law firm of K&L Gates, and I've focused on energy issues and system design issues for over 20 years. I've worked with offshore wind developers and transmission developers, and also for several years in-house with a grid planner and operator here in the US, the equivalent of what you have as TSOs in Europe. And have been very focused over that time on how we think about planning and the regulatory schemes around this. Some of the things Mario mentioned of the frameworks and what the report focuses on in the policy, I think, sections, which are so important. The report itself, I think, the comment was made, the timing is good. The need for consensus can't be overstated, I think, with where we are now in the industry. And what I see from policymakers is they want to know if what they want to do is possible, like, as a threshold level. So they're looking to communities of engineers, this group, to validate that, can we do what we want to do, right? But they're also looking for the education of you can do more than you think, which I think is very important because, as mentioned, we've had the power system over 150 years develop, and it's been a very glacial pace of change for most of that. The basic design has not changed much, and now what we're trying to achieve with it and the technical characteristics are changing all the time. A couple of years ago, you wouldn't do something with HVDC breakers, and now that's an option. So you can do a different design. You can do multi-terminal HVDC. You can do all of these things that make the policy goals more attainable, more affordable. So I think the report is critical in pointing out the change in the technology from where we've come over the last several decades and where we are now, and what is possible and what is necessary in terms of some of the mindsets changes around the policy that I think is driven by the technical innovation, and vice versa with funding and cost schemes and all of that sort of thing. So I think the report is right on track in so many ways, Nelson, and really is adding to the voices coming out of policymakers and technical bodies around the world. And that sort of consensus, I think, is a nice affirmation, one to the next, that helps give people confidence that this is a good direction. This is the right direction that we're headed in.
Well, thank you very much for that really, quick intro. I mean, everybody seems to say we are on track. The timing is now, and that, really we are looking into moving from what I call the analog stage into a digital stage, and we have to look at all this issue. But actually, there's a lot of things we need to cover. So I'm going to sort of try and prep. I mean, we have quite a lot of people online, and I'm going to encourage them to feed us with questions. But before I go to the question from the floor, I just want to tease out a few questions with each and every one of you to start off with. Maybe if I start with Harry in that order and come back to Theodore, that'll give you time to sort of settle in. So let me start with Harry. As outlined by the findings of our State of the World report, can you explain how DC system contribute to the achievement of the SDG in terms of reducing energy waste, improving energy access, and creating sustainable urban environment? That's to you, Harry. What's your take on that?
Yeah, thank you for the question. I think the most feasible example is actually the USB socket today, what we're using on the mobile phone. That Apple doesn't sell anymore the adapter with the phone, and that gives them the opportunity to just sell one package in the world. And that the interesting part of that socket is unified, so that is standardized. And this is, I think, it's very important. Looking to the e-waste, is that you want to harmonize in the world technology. Otherwise, you get specific technology per country, what is making it more complex. And the other topic, what is very important to understand in DC, if you look into every power supply, every piece of electronics, what we're using today, and that's almost every part of equipment, there is a power supply inside that device. And 1/3 of that power supply is actually the AC-DC converter. And if you're looking into the grave belt of failed devices, it's the AC-DC converter that has failed. So the reliability part is really on the DC side from the converter. So from that point, the lifetime of electronics will be dramatically expanded if you feed them directly from a DC system. So from that point, on the material side, we have a huge saving. And if you look to the fairness and energy system today, we have still a lot of developing countries who don't have access to electricity. They start developing systems based on DC in a very practical way. And what we see actually happening is that is the USB-C is there a very important topic in, is that you get more and more equipment that doesn't matter anymore if it's installed in rural areas, in homes, or in very well developed countries, even on boats. For example, you see the same structure moving there. So you see a whole system from energy access on all levels merging in the same direction. So that's why I think, and then of course energy efficiency and all these other terms are playing an important role. But I think the e-waste is one of the biggest driver, and to save raw materials inside equipment. And with DC, you can save dramatically on copper and cables.
Standardization, uniformity, I hear that one, and the issue about saving. So thank you very much for that. Let me bring Ahmad into it. Our friend, you have been actively involved in standardization body, and State of World highlight that the significance of standardization and framework. Can you please elaborate on the importance of the standardized practice for DC system in the future of energy information? That's to Ahmad, please.
That's a good question, Nelson. Of course, as what Harry mentioned, standardized practice for the DC system play a crucial role in shaping the future energy infrastructure. And basically, standardization fosters the most important things about interoperability among various components and systems in energy infrastructure. So that in that case, when you have this standardized for DC system, so a different manufacturer can develop DC devices and equipment that seamlessly integrated with each other. So in that case, facilitating the creation of comprehensive and efficient DC system. Also, I see from a standard point of view, when you have guidelines, this guide also provide understanding how to design and install and operate the DC system. So without this guidelines and standardization, it's going to be challenging to spread the technology or DC technology worldwide. And basically, for market point of view, it's also important. All the manufacturers, they would like to have a standardization for DC system, because in that case, we have like an accepted standard, create level playing for all the field for manufacturer, encouraging basically competition and driving technology advancement. So yes, it is important, and I'm also really keen like that we touched base on the topic of standardization, because I see it as an important topic if we need to unlock the full potential of DC technology and accelerate the transition to a sustainable energy and build resilient and efficient energy infrastructure.
Thanks very much for that. Can we bring Luigi up? Luigi, your industry contribution to our report presents an interesting case study of storage technologies. Can you explain how advancement in storage technology like battery energy storage system help to contribute to the grid stability and reliability within renewable power system? That's to you, Luigi.
Sure. So we have heard something about the penetration of renewable energy resources in the power system. We have to achieve the target of 2050 of maximum temperature increasing of 1.5. So what we can do is to, of course, reduce the greenhouse gas emission. We have to replace the traditional fuel power plants with the renewable energy sources. But there is a drawback, of course, in this way, because the wind energy is not fully controllable. We cannot turn on the sun when we want. So we have to find out other flexible resources that can, let's say, compensate this problem, this feature, characteristics of renewable energy resources. So what we can do? We can, of course, using approach such as the demand response or battery energy storage system. Energy storage system in the field of storage is becoming famous, let's say, because we have a lot of development in this technology, in particular in the lithium-ion battery, thanks to the EV market, of course, that is growing a lot. Also for the stationary application, for the BESS system, we can, let's say, catch all the improvements, technology improvements. And this, let's say, brings the storage, the BESS, battery energy storage, to a very competitive cost, because nowadays, Bloomberg declare an overall cost of a BESS lower than $300 per kilowatt hour. That is very competitive compared to hydropower plants or other kind of storage solution. So this means that we can use this kind of the technology for a lot of business case. And we can, for instance, couple the energy storage with the renewable energy plants. We can make it make the rest plant controllable, fully controllable, such as a traditional power plant. Or we can install a standalone system in order to provide ancillary services that are more and more requested by the TSO or DSO. So yeah, let's say that with the improvements in the battery technologies, we can face the upcoming problems on the power system. So there is a way to go ahead in this energy transition, of course.
Well, I can see that, Luigi, because somebody was telling me the other day that Elon Musk may decide that he does not want to do Tesla manufacture the car. All he wants to do is just the battery, because this is like saying Intel inside the micro, because everybody wants the battery. Battery is going to be the thing. How do we make sure we have the battery that is long lasting, can carry things? So you are absolutely right. How do we capture your renewable and actually be able to put that into battery? That's going to be the real challenge going forward. So thanks very much for that, Luigi. Let me go to Mauro, please. There will still be a need for significant investment in transmission, whether we like it or not. We have to transmit. And even though if you want to do, what I call local distribution, but power connection and transmission, as outlined in the report, they may form key part of the energy system. So HVDC is evolving. Where is the technology now, and what role can it play in the future? That's to you, Mauro, please. What's your take on that subject?
Yes, that's an interesting question. Let's say I can start saying that, let's say HVDC, so high voltage DC transmission. So here we are talking about normally very big systems. So let's say hundreds of megawatt, gigawatt that are transmitted. Let's say the history started, I would say, almost 100 years ago. So we are not talking about something that is really extremely recent. Actually, I'm sitting today in a building here that is called Uno Lam HVDC Center. Uno Lam was the doctor that started in 1928 with the development of the first commercial HVDC. And then very quickly, I don't want to make an history, let's say, lessons here, but we enter in the market with the first HVDC in 1954. It was a very small link in Gotland, here in Sweden. And that we were talking about LCC, so line commutated converter technology. Then, of course, the technology has been, let's say, developed during the years. We went from example, let's say, all the way to thyristors, etc. I think the big step has happened in 1997, when beside the LCC technology, that is, we could say the mother of the HVDC, is a very robust technology. We have plenty of links around the world with this technology. Then there has come another technology that is called the voltage source converter technology. So here we are talking about, let's say, in other words, with IGBT, a technology that gives much more controllability and compactness to the solution. So these were actually two things that for the industry has been extremely important to open up the utilization of HVDC into other applications. So normally we were talking about HVDC in bulk power transmission, mainly, let's say, from a big hydropower plant in the middle of China to the load, for example. With this new technology, we are working with, first of all, even offshore, being, let's say, more compact. Then you open up, let's say, offshore wind connection that today is representing one of the biggest part of the HVDC market. But then the other part is that you're opening up the let's say, the operation with weak grids. So AC grids that are requesting support. So it's not only transmitting power from point A to B. And this, I think, is really what is driving the HVDC today, a technology that is fully controllable. So beside, and this is, let's say, the magic that DC can do, is that beside transmitting power, you have the full controllability of the active power that you transmit, power flow, enabling energy market, etc. But you have also the full controllability of the reactive power. So supporting the AC grid, which is today one of the, let's say, the most frequent requirement all over the world. And just to close a bit, where do we stand today? So when we started with HVDC, we were talking about small converters. Today, we have converters that are, let's say, operating well in the gigawatt level. Let's say, recent links also with the voltage source converter that at the beginning was quite limited in power. We are talking about like 3 gigawatt transmission line in one single system. So this is the size that we are. And losses, this is also another thing that the technology has developed a lot. Today, an HVDC station has a conversion loss well below 1% from AC to DC, considering all the components. So of course, this is making the technology extremely interesting for a number of interconnectors, but not only.
Mauro, thank you very much, because I'm going to come back to that issue about the converter, because that's really very important. I mean, of course, it seems to me that we are going to generate more, or we need to transmit, but somehow we need to have a quicker and smarter solution to do that. Let me bring Theodore into the question. You bring wealth of experience in the legal aspect of the energy industry. The report highlights how policy, and you did say that in your introduction, the report highlights policy and regulation will be vital in the transition to the net zero. Can you share insight into how legal framework and regulatory changes impact the adoption of energy system? Because you talked about a lot of advice over so many years. So Theodore, the floor is yours.
Sure. Thanks, Nelson. I think it goes off some of the comments that have already been made around standardization and the impacts that can have competition. But the legal and regulatory framework really drive at base level how you design a power system, right? The technology is there, but companies, they need certainty. They need to know how something's going to get paid for, what's the contracting that supports it. And a lot of the legal and regulatory frameworks that drive how power systems are planned, and that's what we're really talking about here, power system planning, come out of a notion of, well, doing just enough, just in time, not overbuilding it, right? And so if that's your legal and regulatory framework in Europe or the United States or other places of, well, what's your 10-year load growth, let's say, that's exactly what you're going to build to. But the problem with that is that you're going to do very small incremental upgrades, right? I was at 345 kV, and maybe I need to go to 500, but can I tweak a few pieces of equipment and put that upgrade off for a little bit? Or if I'm replacing equipment, do I need to make the equipment bigger, or can I do exactly the same thing that I had before? And if your regulatory framework is telling you that's what you need to do, you're going to have all sorts of issues of recovering costs and getting permitting and everything else. If you oversize something, oversize is even that word has a lot of bias in terms of what you're designing, right? So if the legal and regulatory framework doesn't shift, you're going to keep getting what we've had. And as the report talks about, that's an AC system to take central station power to loads that are located, maybe not that far, depending on the country and the geography, but not designed for the renewable energy transition, and not really capable of delivering. Certainly past the first few projects, which maybe use up the existing headroom. So, Nelson, I think the legal and regulatory framework shifting, and I think we are seeing this, and that's encouraging, to a mindset that looks at power systems differently, as opposed to how we've done it for the last 100 or so years, to where are we trying to go? That's a much different question, right? It was never where are we trying to go? It was like, what's the load growth over a certain period of time? That's the only thing we really care about. What's the voltage stability, thermal performance? Are we good enough, right? That's all. If we're looking towards, we want to integrate 30 gigawatts of offshore wind or 50 gigawatts of offshore wind to a country. If we want to move to inverter-based generation instead of spinning inertia on the system to, creates the voltage support, what kind of systems do we need then? And that is probably going to be a bigger system change than what you need over the next 5 years or 10 years. You need to look, what do I need 30 years from now or 50 years from now? And how do I design that system? And the regulatory scheme then is legislators, regulators, policymakers saying, that's what we need to plan to. This is where we need to go. And you see that shift happening happily. I think, in the UK, for example, DNV report out for Ofgem a few years ago about the difference of doing networked offshore transmission versus radials one at a time. Dramatic things like 70% reduction in the amount of equipment that you need. That has big implications for environmental impacts, cost impacts. And maybe, and this is a regulatory mind shift too, that's more expensive on day one, but it's much less expensive over 20 or 30 years. But that mindset right now, if it's so focused on day one, is going to give you the bare minimum. And the bare minimum is not a good choice policy-wise in terms of unlocking the potential of what this report talks about, the HVDC systems, all of the incredible benefits that voltage source converters bring for voltage supports, and now black start capability to the system, things like that. So it's the regulatory, the policy choices, government saying, we've seen an FIDIC report, we've seen this other report from Department of Energy in the US or wherever it is, saying, here are the benefits of this sort of power system for reliability, for cost, for environmental impacts. Go do that. That's what we want to see. Don't bring us the small, just enough system anymore. That's not what we're trying to do. So that mind shift is going to be, and I think we're seeing it, is going to be critical to actually adopting these types of systems.
But Theodore, I'm going to come back to that later, because I know we've talked broadly in sort of an advanced country where mega, development, mega transmission is always the issue. And some of the area where, the concerns are impacting us actually in emerging country, where they need to think very quickly. And the regulatory framework is not as best as it should be, even though the offtake, the guarantee, the IPA, all of those issues that goes into who is going to pay for it, and if private sector is going to come into all those issues. I'd like to come back to you later on that, because they're really part of the regulatory part, which is very, very critical, whether you are producing in short time or you are intermediate or but I want to come back into Harry. You talked earlier on about, the report finding. My next question to you, Harry, is very much FIDIC represent, engineers and engineering community. And my question, how come FIDIC members and the engineers, because when I read through the report, not because it was produced by FIDIC, but when I read through the report, it talks about engineering needs to be at the heart of it, and be at the front of it, and all of that. So my question to you, how can the FIDIC members, engineers, and communities, work together in advancing individual and local sustainable energy solution and grid efficiency? And I have a real example, that I want to share, but I want to hear your view on how engineer can work.
It's quite a challenging view, because one of the challenges what we had is actually, we talk about the change of the system, and we have 100,000 of experts, a specialist, and how can you manage that specialist can change the system, because everybody's optimizing his own part in the business case.
Yes.
So that is, and that's why, like organizations like Current OS, for example, there we try to bring all type of different disciplines to the same page, to talk to each other, to keep a system vision, but to talk with the experts. And there it comes into the place that you have to build this very high level of consensus. And this is so, and that is one of the biggest challenges that we have actually in the technical society, because everybody is working on its own topic, try to make the business case optimized, but we have to find the consensus and the compromises to make the system work. And that's, I think, that is what is the most needed in
so from your involvement is looking for a holistic solution to the problem. Yes. Where all parties that will contribute to the solution are very much in the early phase of the project development, so they don't get brought in later on when they've half-cooked the project. So early intervention and early role of engineer is very critical to find a sustainable solution. That's your comment. Is that fair?
Yes.
Good.
Yes.
Right. Okay. So I'll come back to that later. Let me come back to Ahmad Eissa. Your experience with DC microgrids, has been pivotal in Schneider Electric leadership in this technology. How do you foresee DC microgrids shaping the future of energy distribution? That's to you, Ahmad. What's your take on that?
That's good point also, and good also to mention to the audience in this webinar that we have two systems for DC system, what we call HVDC, high voltage DC, and low voltage DC, which we are talking about the distribution, which is here. We clarify about the DC microgrid. And DC microgrid, from Schneider point of view, is like they see it as like a potential to shape the future of energy distribution in a several impactful way. So as we discussed about DC microgrid can offer increased energy efficiency, as what Harry mentioned, because the nature of basically what we have so far is we're converting from AC to DC. But what we have, for example, the majority of renewable energy that we have, like in solar or wind, naturally they are DC. So instead to convert it from AC to DC, this basically eliminate this conversion between this type of when connected to the devices. And also I see that the DC microgrid basically enhance system resilience and reliability, which is also important from point of view, as we are facing a lot of life challenging about climate change. So this is important point. And also I see it as a DC microgrid can empower energy independence. And what I mean by that, they enable community building and even individual home, as we mentioned, Nelson, to generate, store, and manage their own energy basically, and promote self-sufficiency and reduce reliance on traditional utility, for example. So an overall DC microgrid, I see it this potential to transform energy distribution by improving efficiency, which is important, integrating renewable energy, what we have, and enhance resilience, as I mentioned to you. And from Schneider point of view, also, we continue to lead in this technology because we envision a future where a DC microgrid play a vital role in creating a more sustainable and reliable and decentralized energy landscape.
So thank you very much on that. I mean, the point you raised is quite important, but I was going to actually pull on and bring Luigi into the play. Can you provide us your perspective on how demand management, energy storage, and decentralized energy production all contribute to sustainable and reliable energy network? That's to you, Luigi. Is that something you can pick up? Is Luigi still with us? Have we lost Luigi?
Yeah, sorry for the microphone. Can you hear me right?
Yes, I can hear you.
Good.
So, yeah. Did you get my question?
Yeah.
Yes.
So let's say that I would like to continue the discussion of Ahmed. So if we want to increase the penetration of renewable resources, of course, we have to keep growing, to install other renewable power plants. But at the same time, there is not a unique solution. At the same time, we should go ahead with on multiple fronts, let's say. For instance, as I told you before, we should exploit the potential of IoT devices that are spreading on the power system, and these kind of devices allows to make the load controllable. So we can do some demand response, the so-called demand response. That is a service, and we can, let's say, change completely the concept of a power system, because in the future, but in the near future, we will be able to follow the generation instead of follow the load. So it's a completely different concept. And another very important point, of course, is the storage technologies again. So if we want to increase the penetration, the storage technology will play a crucial role. In particular, battery energy storage system that is quite flexible, modular. So we can apply this kind of system to small, medium or big applications, from kilowatt for residential application to up to megawatt for utility application. Yeah. So to recap, my answer is I don't think we could have a simple solution, a single solution to resolve the problem of energy transition. We should consider a different kind of solution, changing the load, making the load controllable, adding new storage technology in the power system. Maybe, of course, also improving the technology, because we did the HVDC, for instance. We are able to modify the power flow among the power system. So all this technology will help us. We support the power system in this power energy revolution.
Luigi, it's interesting you raised that. I mean, I was joking about it, about Elon Musk and this issue about Tesla, because the truth of the matter is, you know, Tesla came up and it was the first big battery one, and everybody paid a fortune for it. Now the battery price is coming down, and you can then travel longer. And now people are now saying, how many EV do you need to have in each city, and how, because everybody needs to recharge. So if we can have a better technology and the battery storage issue, surely then that can give us that sort of storage capacity that we require. So it's quite an interesting issue, and I take your point, and I'll come back to that. Let me go back to Mauro, please, from Hitachi. Mauro, just looking through, based on the report, which outlined that there will be a role for both AC and DC system in achieving a sustainable future, what emerging trends and innovation do you foresee on the national and the global scale that we need to be aware of? This is to you, Mauro, please.
Yes, thank you. Yes, well, that is actually a pretty nice continuation from the previous one. So I came a bit where we stand today, but as you mentioned, of course, now we can see, I would say, all over the world. Of course, Europe has been in many sense a bit of a front runner when it comes to implementing the DC at scale in the grids. But I must say we do see a very interesting project all over the world, in North America, Middle East, Asia, etc. So a lot of things are happening. It is clear that let's say, we have a legacy that is, of course, the AC system, and is a good legacy. So it is not one or the other. The two has to actually cooperate and live together in order to deliver let's say, the targets that we have. If we look at what are let's say, the trends, okay, first of all, we said already about VSC and LCC. I think probably one of the first trends that we see globally is that the voltage source converter. It was also a good list from Theodore with all these kind of let's say, new possibility when it comes to controllability, black start, etc. is actually taking let's say, the big spotlight. We do have technology changes mainly on the configuration, because the power is going up. So, for example, bipolar solutions, so solution that can give to the customer the possibility to have an inherent redundancy, and also possibility to serve the system, let's say, stagwise, is something that is important. Then the other, of course, big elephant in the room when we talk about development and new trends is, of course, everything that is connected to the DC grid. And a DC grid is, of course, something that is working normally overlaying on an AC grid behind. There we have, I would say, the technology development are one thing, but we have also other development, other innovation that are not only technology. If we start with the first one, of course, it was mentioned before, the DC breakers. There are, of course, Hitachi Energy has what we call a hybrid DC breaker that has been tested a few years back already with a very high TRL level. But there are also other players. So this is something that is not a taboo anymore. So one can start really thinking about the DC grid and the possibility to have selectivity and DC fault protection. So this is something that we are expecting coming more and more as an enabler in the end for more complex DC grid. We are talking normally what we expect is mainly a radial DC grid to start with. Mesh DC grid, I would say, is always a bit of a trade-off between the extra flexibility that this grid can give you, and this probably the audience in this webinar could do a lot in the future to help finding the right balance between the flexibility that you can get from a mesh DC grid and the need of designing the DC grid, the components, etc., to utilize this flexibility. So going from a single line diagram to a real sizing of the equipment, that will be a bit the trade-off. Another part that is instead connected quite a lot with what Luigi was saying is the coordination, a better coordination between assets. I mean, it's not one silver bullet. So if we're talking about integrating renewable power, we need to have, let's say, grid forming capabilities. Many times we talk about very weak or even passive grids. So you need to have grid forming, you need to have ancillary services, you need to have, of course, energy balance anytime. So what I do expect is that in the future, we will not have the HVDC delivery and then separately a BESS delivery, and then someone that is looking at the energy management system. These things need to be coordinated. So from a flexibility in the transmission, possibility to utilize storage, being BESS, being a pump hydro, being a hydrogen, and also load management. So possibility to work with some more, and I would say also automized load management. So something that can happen very quickly and can be connected with a dynamic energy market.
So
this, I think, could be interesting.
So I hear, voltage converter, configuration, DC grid, DC breaker, and more important, sort of how do you do the load, spreading. So thanks very much on that. I'm just conscious of the fact that we got roughly half an hour left, and I just want to have one more question to Theodore before I open it up to the floor. So Theodore, my understanding is you've written and spoken about offshore transmission for wind farm, and we all know everybody's doing wind farm. Wherever you go, it's all there. How offshore grid can impact onshore planning choices. What policy changes are you seeing that are driving a shift from AC to HVDC system? And are you seeing emerging standard coming out of that? Theodore, what's your take on that subject? I know you've written a lot about that.
Yeah, it's really interesting, and Mauro mentioned that the offshore sector is driving a lot of the HVDC demand, and with that the innovation. And the shifts that are driving the policy choices are really down to what are the costs of the system if I'm going to go at scale, and we talked, Nelson, about smaller needs, or smaller country needs versus larger projects. But if we're talking about larger projects in the United States or Europe, then you're looking ahead and you're seeing your net zero goals for a given year, 2035, 2040, 2050, and you're saying I need 90 gigawatts of offshore wind, or 50, or whatever the number might be, and you sort of just reverse that. Policymakers say, well, how many tri-core AC cables is that? And it's a lot if it's 400 megawatts a cable, right? So I can fit 2 gigawatts or 2.6 gigawatts onto a cable bundle that's like this big. That's incredibly attractive, I think, cost-wise, right? We're talking about less plants. There was a time when, not that long ago, I would say, the friends from Schneider and Hitachi can pin the date. Not that long ago, I think people were thinking, oh, HVDC is so expensive. We have to do AC. And I think the mindset now is, oh no, HVDC is going to be a big cost saver versus doing a conventional system. So cost is a driver. Impacts, I mentioned, number of cables and plants and all of that sort of thing, Nelson, and two sorts of impact. One is, environmental impact, seabed impact, but the other is community impact. How much electrical plant is coming through neighborhoods? And in a lot of places where you see industrial equipment, it tends to be neighborhoods that are disadvantaged. And so there's an environmental justice component to this, of how do you have an energy transition, but not have the most at-risk communities bearing the brunt of all of the industrial buildup of that transition. And the third thing I think driving the policy choices is reliability. And people have talked about, well, reliability issues as a problem coming out of the energy transition. But Luigi, Mauro, I think Harry have all mentioned the AC grid support of HVDC transmission. It's actually a reliability booster, when implemented at scale, that can deal with a lot of issues that you used to deal with StatComs and dynamic voltage devices and that sort of thing. So those things I think are really driving the policy. And now we see that those factors together. So New York State, for example, requires HVDC for offshore wind farms. You are not allowed to use AC at this point. And there's that directive. I think all of the DOE studies in the US for the West Coast and the East Coast all look now at multi-terminal HVDC. And I think this is a global transition, and Europe's leading it. My friends from Hitachi, I think, can testify to the orders that they're receiving from the TSOs and other developers around the world. And that is creating, I think, a de facto standard of 525 HVDC, multi-terminal ready systems, with everybody trying to work on the digital communications to make, Siemens work with Hitachi, work with GE, and all these things as time goes on. But it's the cost, it's the reliability, it's the impacts. And when all of those things align, as you listen, Nelson, and there's a question in the chat here about, well, what are the downsides?
Yep, I'm picking it up. Yeah,
right. We'll get to, probably, there's some things, and it's not always the right puzzle piece, but the upsides are dramatic, and the upsides continue to improve. We're now in a space where, as opposed to something you design a transformer in the 1970s and it's good for the next 40 or 50 years as a design, it's digital now. It's almost like your telephone, your mobile phone or whatever. What we can do today is something that we couldn't do 4 years ago. It opens up new possibilities for the three big policy drivers that I talked about, Nelson. And that in and of itself is driving it forward and driving down costs as we come to those standards, which I think impacts some of the applications for the smaller installations of transformative energy systems.
Well, thanks very much for that. I mean, that to me is quite an insight, because it's a good segue. There's a lot of questions coming from the chat room. I'm sure that people are looking at it, but let me pick them up one at a time. Let's start with the obvious one, which is broader. We've talked about renewables. The question is, are small nuclear power plant considered a solution among other sources that we need to look at? Do we believe? I mean, there used to be a time where you talk about nuclear, don't go there, and then you see now it's part of the base load. So the question is, are small nuclear power plant considered a solution among other sources? Who's willing to take that? Luigi, what's your take? Yeah.
Okay, honestly, I think that it depends on what was our plan, the government plan, because we all know that the commissioning of a nuclear power plant is not so easy. Yeah. It takes a lot of time, many years.
A lot of money.
Yeah. So if we have to achieve a target at 2030, at 2050, I don't know if we have the time to do a new small or big nuclear power plant. I don't want to say I agree or disagree on the nuclear production. I think that as a base load, it could be a solution. But again, it depends on the stage of where we are. So if we have to develop a new power system in the developing countries, for instance, we could consider nuclear power plants, small nuclear power plant. But honestly, I think that there are other solutions more
accessible,
more sustainable,
and safer.
Yeah, and safer, of course. Yeah.
Luigi, I'm with you. I have nothing really against nuclear issue. You're absolutely right. Different countries have different needs. Some sophisticated countries have nuclear power as part of their base load. some have, nuclear power, which they pass their sell-by date. They're now looking at how they're going to decommission it, make sure that it's safe, and build a new one that has all sort of issue that goes with it. And some are looking at it, but I think it is fair, looking at Theodore's comment earlier on, it's important that, for those, what I call less developed country, to go into nuclear as a base load may be a big hurdle for them to achieve because of regulatory and all the requirement that goes with that. So I do take your point that it's not an easy option to consider, particularly the small one, even though in some developed country they said, yes, you can do it. And I know other providers are looking at that. The other point that came across, which I think I want to bring up, which was the issue about, I think if I can get it, can we have a common grid so that every country is connected with the pool of energy, takes out his share where he wants to? Is it possible to have a common grid across? Is it possible? Who's feel like going to? Who's the transmission expert on that? Is it Mario or that? Mario, do you want to take that? Is it possible to have a common grid?
I can try to give a bit my 2 cents. I think that the question is relevant and is actually mirroring a bit what is happening, because I must say, from of course, using my Google as a HVDC product manager, I mean, of course, one part of the HVDC business has also increased because more countries that before were just happy with their grid, they need to be connected. They want to be connected with others. And in many cases, maybe because the grid are not synchronized, or maybe you have 2 different frequencies, then you find solution like HVDC point-to-point or even back-to-back. So let's say an HVDC with no transmission line, just transmit, let's say, changing from AC to DC to AC again. So the need of interconnecting markets is, I would say, higher, probably the highest has ever been before. At the same time, trying to answer a bit the question, of course, there are limitations, because anyway, let's say the energy needs to be transmitted. So if you look, for example, Europe as an example, is a very dense mesh grids. So you could say that in the European area, then you have actually one energy pool, let's say, that you can utilize quite effectively. But then we have other mega projects that are on the, let's say, on the radar today. Probably you have heard about Sun Cable, Australia, Asia interconnectors. That we are talking about more than 4,000 kilometers cable. There are other projects like connecting Morocco to UK. So of course, if you reach these kind of distances, then even with HVDC, not because maybe of the conversion station, but the line, etc., will represent a very important loss. So of course, there are some technical limitations. But overall, I think the world is trying to be more connected. And then, of course, it comes all the geopolitics behind that maybe drives in other direction. But from a technical perspective, more connectivity, better sharing of ancillary services, better sharing of energy, etc. So it is going in that direction in some way.
Well, believe it or not, in the FIDIC contract are being used on interconnector between Europe and North America. So I know that, and I know the issues that goes with that. And Theodore, who is an expert in the legal sense, know they try to use standard contract that is being tried and tested, and we get people coming up to say interconnector between Europe and North America and Canada. So I do understand the point. And let me just pick up another question from the floor. And there's a lot of questions here. We can't cover them all. But one of them they raised was to do with issue about risk. And I think it was raised that it would be worth to hear about the risk and concern identified by US team panelists related to the use of DC system instead of AC. Are there a risk? Is it big risk? And is it manageable risk, or is it myth? So who wants to go? Luigi, or who wants to go? Ahmad? So who is brave enough to go for that? Are there risks using the DC?
It depends on which risk level you ask. If you ask it on the LV side or you ask it on the HV side. So there are different risks in both parts of the systems. And I'd say, and if I can answer the question, if I looking at it from the LV side, I think it's incredibly decreasing the risk, because one thing we have to understand, that we get more and more depending on our electrical system. And so that means we want to have more continuity of service in the grid. And that's why microgrids plays a huge role in the LV part to guarantee supply. So I think DC microgrids could be actually dramatically decreasing the risk of losing distribution or transmission in a certain area. You can think about the disasters, hurricanes, earthquakes, where then availability of microgrids can just decrease the risk. And that is I can answer that from the LV part, and from the HV part I cannot answer that. I think that is to the other specialist.
Ahmad, do you want to jump in on the DC side? Any risk that we need to be? How risky is it? I mean, everything we do in life is risky. We go to bed at night and wake up in the morning. There's no guarantee you're going to get up in the morning. We take risk. So, there's a low level risk, there's a high level risk. And in this case, is there a perceived high level risk with DC?
Well, I completely agree with Harry in point that when we're talking about the low voltage, because I'm not saying that there is no risk, there is a small risk, but you need to see also the full picture of when you have a full a DC microgrid, what the benefits, and you see the percentage, how much the percentage, okay, 70% is good, 30% risky. So in that case, we need to compromise about what type of risk we need to take. But there is risk, for example, one of them about protection, for example. So this is because people, they think about the voltage level we are talking about in distribution is maybe still a high voltage. So how are we going to make sure that the system protected? And that's why Schneider, they work really hard to implement, to design protection, can also eliminate this risk. And this is what we've done in the DC system and Schneider Electric. So it is important to mention about the benefit, but also I can tell you that there is a risk, but it's not the risk that what people, they think about it when we're talking about the low voltage. I don't know about the high voltage. The high voltage, maybe the panelists, they have a different view about this.
Okay. So who else wants to jump into this conversation? I like to have different perspective on the subject.
No, but I can jump into
please come back, Harry. Yeah, please.
One important topic what we all the time missing actually is that we talk about the transmission system and we assume that the market is always a consuming market. And that brings the complete fairness to all the people, because all the people consume. So it doesn't matter where you are in the system, you pay the same price. Okay. But the big risk, what I see happening now today, is that the energy transition could become negative perception at the user level, because some users can consume energy, can produce energy, while others cannot do, because their house is in the wrong orientation, they're living in an apartment. People can charge at home, some people have to charge on the street. So you will see a huge polarization in the society of energy access, energy production. And that brings, a lot of misunderstanding between neighbors. So it could actually destabilize the society. In particular, and just to give an example, if you bought a house 20 years ago at the same time as your neighbor, now suddenly if you are in the wrong orientation, your house has less value than the house of the neighbor, just because of energy labeling, just because of the orientation. And if you are unlucky, you have trees in front of your house. You cannot use solar, but the trees are contributing to the neighborhood. So you get a whole discussion about fairness in the energy system. And I think the regulators has to do a lot of things about that one. And technically, I think that DC microgrids, when it comes to microgrids, it could be more a social driven system where you share PV and you share EV possibilities. And that can dramatically decrease the risk of angry people. So there's not a technical risk, but I think it's a social risk in the end of the day.
Right. Well, risk is everywhere. I mean, there's another question here, which is to do with interconnector. I mean, transnational interconceptor. The question is, do you see any risk associated with increasing use of such interconnector? For example, increasing exposure in country A to environmental and geopolitical issue in country B. I suspect, this is something that's always happening. Is there any view on that subject? Is it Harry that going to jump into that, or
I can try to take it at least to start with.
Okay. Yeah,
I think it's a bit connected also with other question about the risk, especially going into DC. And of course, then one can have an interconnector in DC, but it's very similar to having an interconnector in AC. So we could also have, let's say, big transmission corridors in AC. In my opinion, if we look from that perspective, the risk is, if we like, lower in the sense that you have a better controllability of this link. So of course, there must be the framework around, etc. In my opinion, from a technical perspective, I do not see increasing risk with DC also when it comes to reliability, etc. I do see, however, one challenge that maybe is something that consultants around the world and policymakers should really think about, is that the DC, especially if we're talking about big sizes, is coming from, let's say, very tailored, bespoken, big project. Theodore was saying before, it was expensive. So a customer buying an HVDC expects a lot of tailor making. Normally you get years in planning, years in making. That was acceptable before. If we look where we are today, I think we all need from technology providers, but also from customer policymakers, engineering owners, to think about how can we do things easier in terms of both planning and procurement and construction. And this, for me, is something that we, as an industry, we are working on, but is probably a risk that we, let's say, we lose time. If we continue to work as before, every single project is very, very specific. Of course, the timeline gets longer and prevent the possibility to make changes in the procurement process as well.
Okay, I'm going to change the sort of the tone and the direction of travel now, just trying to get a fair balance of questions from the floor. There is one question which is really about developed country and emerging country and learning from each other. And one of the questions that came through is, can we share experiences between developed and developing countries? And I'm thinking about Africa here. I think it may help adaptation if we are unable to achieve the SDG number 7, being specific here. So who wants to jump into that? So can we share experiences and learning from each other? Question.
Maybe I can say something about it.
Please. You are in China right now, so I won't consider China
yes.
emerging country, but please tell us, please.
Now, there is a big project in the IEC on the system committee FIDIC, where we have a special dedicated working group to share standards and technology to make the Sustainable Goal 7 feasible in developing countries. So that is one of the topics that we try to address it, to bring standards in that field. So that, because that is one of the, one of the problems today, is that there are 10,000 different solutions that makes it very expensive to scale and to implement. And that work is massive. What is in the background going on? So, and in that case, it will develop as an emerging market in that case, because from the customer point of view, but also from the social point of view, if we can achieve energy to everybody on this field, it brings a lot of peace and a lot of things to the society. So, so I know internally there's a lot of work going on this one.
Okay.
And this is a lot
of want to add on to that? Yes. Anyone else want to contribute to the subject? How do we transfer knowledge and how do we share experiences?
Sure, Nelson, I'll talk to it for just a moment. I think there's the experience that we can share on the technology, certainly, and Harry mentioned it. Some of it I think just happens because of where the industry is going. Right. I mentioned some of the de facto standards coming out of HVDC, right? That's the North American market benefiting from the European market, but then others, as a Prysmian or an NKT, they're scaling up a certain product line and that becomes more affordable and available. You don't have to bespoke develop the HVDC project, again, there's a economy of scale that's been built up. And I think of that as a sharing of, a lot of folks' R&D investments can benefit a wider pool, right? That's a great function of building up the supply chain. And then I think, on the policy side, emerging economies or smaller economies can look at what are the key issues that have either enabled or stalled projects, whether they're microgrid projects or generation projects, and can we skip the heartache of maybe 5 or 10 years of failed paths and go to something that may or may not work a little bit better, adapted for each area. And so there's certainly, I think, more than I've ever seen before, both on the technology and the policy side, a global sharing of, what are the issues, what works, global standards organizations, but, and webinars like this, which I look in the chat and it's just from all over the world, people listening and sharing ideas around some of this. And I think that, it might be a sharing too of, what can work most cost effectively. It might not be that, a smaller economy wants to do what a larger country did, but there's a question, Nelson, around, is there a danger that with HVDC or whatever, some countries have a worse environmental picture for the benefit of another country. I would say something like that was much more the case with thermal generation, right? Where you had a lower fuel cost here and you could transmit it to somebody who had a target. I think that what we're talking about here with the modern energy system, the HVDC, enabling the renewables changes that to a situation where you can have generation with free fuel costs, solar, wind, etc., transmitted to a place that can displace, diesel generation, for example. And the technology that's developed in one place can really expedite the creation of those sorts of energy sharing systems to other places. So that sort of benefit sharing, I think, is on the table too as we move through this transition.
Put it this way, yeah, thank you very much for that. Yeah, I think, we are now coming towards the final part of the webinar, and I really want to now give each panelist, an opportunity to have that sort of one sentence striper to say, yes, the report is now being produced, and this is my observation. And we've had all this conversation going away. I hear in this report so far talk about the engineer need to be involved, all the stakeholders need to be involved as early as possible to find a holistic solution. Moving from the old into the new is quick. So I'm going to start off, with Harry. And what would be your one sort of sentence, not more than one, that you just want to leave us with in terms of, going forward to be positive about this thing? And I'll come back, to Ahmed as well.
DC is our last chance to get a common system in the world.
Okay. This is the last chance to capture. Yeah. Okay. Last chance. Okay. Ahmad, yes. What's yours?
What I see, we need to collaborate, all the stakeholders, industry, standardization, regulatory bodies. So all of them has to be collaborate to make this happen, to expand the DC system everywhere.
Thank you very much. Yeah, thank you. Luigi, what's your takeaway?
I'm thinking about it, but could be if we want to increase to achieve our target, probably we have to share our knowledge. We have to share and knowledge share, of course, but share also energy community. we talk about community and energy community, and yeah, and this is a very, let's say, complex topic, because when we talk about the energy community, we talk about HVDC, low voltage ADC, we talk about battery energy storage, we talk about renewable consumers, and so on. So
So it's knowledge sharing and energy sharing.
Knowledge. Yeah.
Yes. Mauro, what's your last sentence that you want to share with us, leave with us? What's your...
I must say, what I was thinking is very, very connected with what Luigi said. I could maybe just add one word, that is explore. So for the people that probably start, let's say, will get quite a lot from this report with the DC. We talked today. We don't have a single silver bullet. So let's us exploring, and then as Luigi was sharing, we need it.
Thank you very much. Theodore from United States, what's your one sentence that you want to leave with us?
Thanks, Nelson. It's about mindset. And I think, there's great consensus coming out of a discussion like this, and certainly in the report about what's technically possible and where we need to go. But there's a role for all of us on the collaboration and the exploring. And I think for this transition, the mindset is important, and key among that even might be unexpected, which is people who have been doing engineering and grid planning for a long time. It's not scary to move to new designs and new things, even though there's a strong preference for repeating what we've done for decades and decades. It's safe, we know it. But that mindset changing, I think, will be key to embracing some of the systems that this report talks about.
Thank you very much. I just want to wrap up at this point. I know that Basma has been listening at the back of the conversation. I'm sure you pick up a lot of issue. Let me just pick up the report. If I've got it right, set out 4 recommendations. One is that clients should procure solution with specific link to the SDG outline and talk about early engineers' involvement. Modern power system involve a complex delivery of multiple type of projects that comes across loud and clear. Significance of societal and community focus. Then the significance role of the policy framework. So all of that is being covered. I did ask our eminent panelists, and I'm just picking up the big buzzword that came out of that, which is last chance for DC to solve. Issue about collaboration, issue about knowledge and energy sharing. I also hear about exploration and prepare, to break the traditional mold. Don't always go back to what you also prepare to explore. And I hear loudly, if I can pick it up, Theodore, talk about mindset. We should move from the traditional way of doing it, not be locked down into the old way of doing, but prepare to explore and prepare to take a new way of looking at it. Nobody has all the solutions, but it seems to me that the energy issue, I'm going to move forward now in terms of thanking all our speakers. Thank you very much for your time, for your contribution into the report. Thank you to, State of the World webinar sponsor, Schneider Electric, for all your contribution to the particular discussion. I know that, different people from different parts of the world join us. I want to reference our climate change charter. It says there on the screen. If you haven't downloaded, please, sign up to this. This is recommending to all stakeholders. Everything I've had today is about the industry working together, including end user. This particular charter call everybody to action to do something if we are going to achieve the sustainability development goal. So whether it's an individual, whether you are a FIDIC member association or project team or individual, please have a look and give some commitment in the process. Moving forward into the next stage, I just want to remind you, we do have our, contract users conference coming up, which is going to be in November. If you haven't registered, please register. It's interesting, the subject we're looking at there, looking at how do we green our contract and how to move things forward. I want to use this opportunity to say massive thank you to the FIDIC staff behind the scene, Basma, Andy, all the people there who've been putting the program together, Beatrice, Nadia, and all of that, making me look much better than I am. But more important to the audience, we've got different people from different parts of the world who's joined us. I hope you find the session very useful. The video will be available on social media, and you can have a look at it, when you have the time. And for those who are unable to join us, I'm sure you can have the opportunity to follow them. So once again, thank you to our panelists. Thank you to our team for putting it together. And I hope that the State of the World report will be very there for people to use as a reference point. So wherever you are, keep safe. Take care. God bless. Bye.